Let's put together a couple of the things that we've learned this week. Probably the most important rule for the derivatives that you've learned this week is the power rule, and that's the one I have written on the board behind me. The power rule says, if I take the derivative of the function x to the n, the result is n times x to the power n minus 1. So I think of the exponent as jumping down on the front of this variable here, and when that happens, I reduce this exponent by 1. Remember, I have a bunch of different notation for what it actually means to take the derivative, and this is just one of them. We'll see some more later along the course. So the power rule is pretty powerful, but it's not the only rule we have. We also had a rule about what happens to the derivative of a sum, and also we talked a little bit about what happens when there's a constant on the front of a function. We're going to put all those together and start taking the derivatives of polynomials and functions that look kind of like polynomials. We'll start doing this in this video and finish up in a next video where we do a couple of more difficult examples. So here it goes with our first examples. Here's our first example. I have f of x 3x squared minus x plus 14, and what I want to do is find the derivative of this f. Again, I'm using here the prime notation for the derivative. This function is a polynomial, so I'm anticipating that I won't have too much trouble. After all, polynomials are my favorite kinds of functions. So we know about the power rule, because I just reminded you of that. And we also know that if I have a whole bunch of functions added together, I can take the derivative of each one of them individually. So I can take the derivative of 3x squared and add that to the derivative of minus x and add that to the derivative of 14. That's exactly what I want to do. So the derivative of this function, 3x squared minus x plus 14, is equal to the derivative of 3x squared minus the derivative of x plus the derivative of 14. That's what we just said that the sum rule gives us. Now, here on the 3x squared, I have this coefficient of 3 on the front of the x squared. Because it's a constant, I know that I can factor that out of the derivative and then look just at the derivative of x squared. So let's go ahead and do that. So what I have here is 3 times the derivative of x squared minus the derivative of x plus the derivative of 14. Okay, here I can use the power rule. Here, the derivative of x I know is just 1, and here, the derivative of a constant is just 0. So I have 3 times the derivative of x squared, which is 2x. Using the power rule, the exponent jumps off the front and then goes down by 1. So when I don't write the exponent here, there's a little invisible 1 on my variable here. Minus the derivative of x is just 1. I can think of that again as the power rule, this being x to the 1 jumps off to the front, and then the exponent goes down by 1, 1 minus 1 is 0, and x to the 0 power is just 1. And then here, the derivative of 14 is 0. So, cleaning this up a little bit, 3 times 2x is 6x minus 1. That's the derivative of my function. Cool. Let's move on and do example 2. In this case, I'm given a different function. Here, f of x is equal to 6x to the 7th minus 4x to the 3rd plus 6x, and I want to find the derivative of this function. Again, I'm using the prime notation to denote the derivative. This function is still a polynomial, so I'm still feeling pretty good about myself, and this time I'm going to shorten the explanation a little bit because I don't need to write all of those steps every time. I still know that I can take the derivative of each of these terms individually and add them together. And I also know that I factor out the constant on the front of each term. So, writing this with a little bit more shorthand notation, I have f prime of x equals 6, that's the constant, times 7x to the 6th power, minus 4, that's the constant. Now I use the power rule on x to the 3rd, so times 3x squared. And then finally, plus 6 times the derivative of x, which is just 1. That was even faster than last time, but I still have to clean things up a little bit. 6 times 7 is 42, so 42x to the 6th power. 4 times 3 is 12, so I have minus 12x squared. And 6 times 1 is just 6. Cool. So this is my answer for example 2. Again, since it's a polynomial, I just write out all my terms like this, and I end up with 42x to the 6th minus 12x squared plus 6. Finally, let's look at example 3. In this case, my function's not exactly a polynomial because most of the time we think of polynomials as having whole numbers on their exponents. And here I have fractional exponents, 2/3 and 2/5. But because these exponents are not 0, I can still use the power rule on these guys. So we'll go slow again. I want to take the derivative of this function, x to the 2/3 minus x to the 2/5. The sum rule says that I can take the derivative of each of these components individually and then add them together, or in this case subtract. So this is the derivative of x to the 2/3 minus the derivative with respect to x of x to the 2/5. Okay, so what does the power rule say? I don't have any coefficients to deal with here, so that's a little bit easier. The power rule says I take the exponent, it jumps off, and then I subtract 1 from what I have left here. So the derivative in this case, the exponent comes down on the front, 2/3, and then I have x to the 2/3 minus 1. Over here, I take the derivative of x to the 2/5, the exponent jumps down, so I have 2/5, and then I have x to the 2/5 minus 1. Alright, so I have to do a little bit of fraction algebra, but that's not so bad. I end up with 2/3, x to the 2/3 minus 1 is x to the negative 1/3, and then I have minus 2/5, x to the, well, 2/5 minus 5/5, that's probably negative 3/5. And so my answer in this case is 2/3 x to the negative 1/3 minus 2/5 x to the negative 3/5. That wasn't so bad after all. So what we've seen in this video is that it's not so bad to take the derivatives of polynomials as long as we're combining together all the things that we've learned about the power rule, the sum rule, and what happens when I have a coefficient on the front of my function. Make sure you do some practice exercises like these. This is not going to come easy at first, but I believe that you can get the hang of it after a little bit. We'll do some more complicated examples in the very next video. Good luck!